Yes! This is a great day. Bonsuelo, everybody. Word problems, things of beauty, things of wonder. Okay, what I'm going to do here is I want to get through as many examples as we can. I'm going to try and get something across here. And so I'm just going to set them up. After that, it's you should know how to finish them off. If you have questions on that, come and see me, come talk to me. But I'm just going to set them up. Okay, I'm not going to tell you really much new here. It's this. Okay, this is the two variable, two equations section of ALEKS. Therefore, you have to solve every problem here with two equations and two variables. Is that true? No. Most of them you don't. You always want to try and use as few variables as possible. So what I'm going to try and get across here, because other than the basic plan, define what you're looking for, set up your equation, that's as far as we're going to go with these, but then you'd solve and then write, then check it. That's not going to change, okay? What I'm going to try and get across is how do you know when you have to use two variables, and how do you know when you can get away with just, or not two variables, but two different variables and two equations versus you can just get one variable, one equation. That's what I'm going to try and get across. I'm going to try and do this with as few variables, few equations as we can. If you look at any of these problems on ALEKS in this section, back in chapter 1, what did they do? They did it with one variable and one equation. And now what do? The exact same problems. They do it with two variables and two equations. I say, why? 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 I don't really see the point. So, but you can do it that way. That's fine. Okay, so let's take a look here. What are we doing? Okay, blah, blah, blah. You can read the first problem. What are we looking for? How many boys, how many girls? Okay, again, I always like to make the definitions first and then assign the variables. So number of boys and number of girls. Okay, does it matter which one we know first? Probably, since it says you have 15 more boys than girls, probably want to know the number of girls first, but it's not that big of a deal. And then the boys would be x plus 15. Okay? Okay, so what's the biggest piece of information? Total students. Equals 43. I'm not going to belabor this. So then we'd add up the number of students, x plus 15 plus x equals 43, and then you'd solve it. That's it. Okay, now for this one, and I'm not going to keep doing this because it would double the length of everything we're doing. I'm going to show you what ALEKS is going to do in this. So you don't need to write this. I just want to show you. They're going to say, and I'm going to go for the shorthand here, number of boys, number of girls. They're going to call this x and this y. They're going to say there are 43 students, x plus y equals 43. And the number of boys is 15 more than the number of girls. So you have two equations, two variables, and I'll solve it by substitution or elimination. Yeah, you can do that. Really, it's no problem. I just figure why bother. That's all. All right. It's probably about the only time I'm going to say this. But so again, I'm erasing it not because there's anything wrong with it. I just want to emphasize here, when do you need to use two equations and two variables? And here you don't. It's fine if you do, it's fine if you don't. Okay, blah, 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 blah. What's the total cost of each? Okay, what's the length of time of call? So x is going to be time of call. Okay, now remember, you always want to figure out what's this thing about. Like this first problem, this was about boys and girls. What's this about? It's not about money. It's not about time. But it's about plan A and plan B. And what does this problem say about plan A and plan B? The 17 is not about both of them. It's about A only. The 11 is not about both of them. It's about A only. 22 is not about both of them. It's about B only. 9 is not about both of them. It's B only. So what does this say about both of them? It says the total cost of each plan will be the same. So the A cost equals the B cost. That's what this problem says. Okay, so how do you figure out the cost, okay? You have the fixed cost, the basic cost, plus the cost for the time. And that's for A. And of course, you'll have the same thing for B. You have the fixed cost plus the time cost. Okay, what's the fixed? Do we know any of this? Yes, the fixed cost for A is $17. The fixed cost for B is $22. Well, how much do you get charged for the time? Well, it's basically rate times time. And again, remember, you don't need to write all this. This is what you do when you don't know what to do. So if you go straight to the equation, that's fine with me, as I've said. Okay, so there's 17 plus, what's the rate of A? It's 11 cents. And what's the time? X. For B, what's the rate? It's 9 cents, which is 0.09, not 0.9, but 0.09 times X. At this point, what would I tell you to do? Multiply by 100 and get rid of decimals, et cetera, okay? And by the way, on each of these, as always, I suggest you try it yourself and then see how it goes. And then, then watch the video for that particular one. So pause it before each problem. Okay. Speed of each car. So we have one car speed, so the speed, then we don't really define the cars anyway, the speed of one car and the speed of the other car. Okay, so one car goes 13 faster than the other car. Okay, so it doesn't say which one's which, so I'll just say the other car goes X, and this goes X plus 13. What's the biggest piece of information here? Remember, this is not about distance, rate, or time. This is about two cars. So whatever you tell me, it's got to be about both cars. Okay? So now, there are two things here. There's the 13 kilometers faster. That's about both cars. But remember, we're looking for speed. So you want it to be about the two cars, but not about the thing we're looking for. Okay, now, something kind of deceptive here. If the cars meet in 6 hours, okay, now is that 6 about both of them? I know it kind of seems like it, but it's not. Is their combined time 6 hours? No, each one individually goes 6 hours. That's kind of a fine point. If you have a question on it, ask me. But the 6 hours really is not about them together. It's each one individually goes 6 hours. So what do they do if you want together? The total distance equals 1794. Again, how do you find a total? Not always, but usually the distance of one car plus the distance of the other. Okay, so how do you find distance? Now we can talk about rate times time. For each one. Okay, so let's fill in what we can. Okay, so the rate of the one car is X plus 13, and its time is 6. The rate of the other car is just X, or the first car. and its time is 6. Now, let me point out something. At this point, you'd finish it off. But I just want to point out, instead of distributing the 6, why don't we divide away the 6? Because the 6 is in each term, right? This is one term, this is another term, and this is another term. And there is a 6 in 1794. Okay, because if it was 1800, which is close to 794, it's just 6 short of 1800. Your 1800 divided by 6 would be 300. 1800 divided by 1794 would be 299. Okay? And then if I divide these by 6, I get x plus 13. And this would be x. And that's a lot easier to solve than the one with all the big numbers. Okay, but the basic idea is still the same. Okay, 60 less biology books were sold than math books, blah, 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 blah. So what do we want? How many of each type of book were sold? So we want the number of biology books and then the number of what math books? The superior math books. Okay. So, does it matter which one I know first? Well, probably we want to know the math books first. And then there's 60 less biology books, so that'd be x minus 60. Okay. So what's the biggest piece of information of here? Total books. It's 238. Let's not belabor this one. It should be pretty straightforward. So it'd be x minus 60 plus x equals 238. Okay, pretty straightforward. Let's take a look at the next one. Cost of each type of math book. Notice, don't just put, like on number 4, don't just put biology books and math books. On a number 5, history books and math books. Because I'm asking for different things. In number 4, I'm asking for the number of books. And number 5, I'm asking for the cost of one. Okay? So we have the cost of a math book. And the cost of a history book. Okay. So, which one do we want to know first? I don't know. It doesn't really seem to make much difference, so I'll go for the math one first. Now, what's the cost of a history book? Okay. This is the first one we've done where you have to use 2 variables. Why? Let's take a look at number 4. In number 4, we want number of biology books, number of math books. Do they tell us a relationship between the number of biology books and the number of math books? Yes, they do. Number 5, we want the cost of a math book and the cost of a history book. Do they tell us anything about the cost? That's a relationship between the cost of the math book and the cost of the history book. No, they don't. So here's where you have to have 2 variables. That's why it's so important to define your variables first and define it clearly, not just math book and history book. Okay, but the cost of a math book and the cost of a history book. And do they tell us any relationship between those 2 things? No, they don't. Okay? So that's where you need 2 variables. And if you're not defining your variables first, you're going to miss that. Okay, so, we have 2 different variables. Therefore, we need 2 big pieces of information. So what would we have? The first total, remember this is not about money, this is about math books and history books, is 109, okay? The second total is 111. Now, to try and save some time on this video, I've already gone through before, like how do you figure out the total? You add them. So the first equation would be the cost of the math books plus the cost of the history books. Okay, actually both of them would be that. Okay, how do you figure out the cost of the math books then? Well, it's the number of books times the price of each book. Okay, so if I can write this. So for the first total, you'd write math books plus, I'm trying to save a little space here, math books plus history book, cost of the math books plus cost of the history books equals 109. For the second total, you'd write cost of the math books plus cost of the history books equals 111, because it's under two situations. Well, what's that? The number of math books times the price plus the number of history books times the price. And again, you can abbreviate. And then we'll do the exact same thing for the second day. The number of math books times the price plus the number of history books. And this idea that a total's the sum of two things, and then the cost of something is the number of items times the price of one item. So that's why I'm not going into a lot of detail here. Okay, and now we can write an equation for each of those. Okay, what's the number of math books? 5, the first day. How much does each one cost? X. What's the number of history books? 2. What's the cost of each one? Y. That equals 109. Okay, the second situation, we have 3 math books plus 5 history books. And again, do you have to write all this stuff? No. What do you have to write? You have to write the definitions and then the equations, okay? This other stuff is to get you there if you're having trouble. But the point I'm trying to make in this is you need 2 variables. Why? Because the 2 things we're looking for, the cost of a math book and the cost of a history book, they didn't give us a relationship between any of those 2 things, okay? They didn't give us a relationship between those 2 things in the problem. Okay? All right. Let's take a look at number 6. What do we want? How long will it take the Mustang to catch the Camry if it goes 89 miles per hour? Okay, what are we looking for here? We're looking for the time, not just time, because the Mustang and the Camry have different times. Okay, and we're looking, how long will it take the Mustang? So it's the time of, or for, the Mustang. Okay, now at this point, again, I've mentioned this before, you may define something else if it's important and unknown. So you may want to define the time of the Camry, but it's not exact, it's not necessary. It's whether it'll help you or not. That's what you do. Okay, so I want X to be the time of the Mustang. All right, so what happens? The Mustang leaves 5 hours later. Okay, now, some people think that would be that the Mustang's traveling 5 hours more. No, the Mustang's traveling 5 hours less. So what happens? If the Mustang's traveling 5 hours less, then the Camry is traveling 5 hours more. Why? Because it's out there driving around while the Mustang's just parked. Okay? Now, could you do this? And I'm going to write something else down, but don't you write it. Could you do this? The Camry equals X and the Mustang equals X minus 5. Well, yes and no. You may do that, but I think it's going to be a mistake. Why? Because then when you come up with X, you've found the Camry, and you're not looking for the Camry, and you might think that's the answer. Okay? So define the thing you're looking for first, And then the second definition here, that's your call, whether you want that or not. It is not necessary. Okay? So I'm going to do this as if we didn't define that. All right? So I want to show you what you do if you didn't. It's perfectly all right not to. Okay, so we want the time of the Mustang. Fine. Okay, so what does it say? Well, the Mustang leaves 5 hours later. Well, I don't want to use that as the biggest piece of information because that's regarding time. Okay? Well, this one's a little more obscure. Okay, what happens? They both leave the same city. They travel the same route. Okay? Well, the 62, is that about the, remember, what's this about? The Mustang and the Camry. Is that 62 about both of those? No, so it's not that. Now, the statement 5 hours later, a Mustang leaves the same city, is that about the Camry and the Mustang? Yes, but I don't want to use it because that's about the thing we're looking for, which is time. Okay, then how about the 89 miles per hour? No, I don't want to use that either because that's only about the Mustang. So what does this say about both of them? They leave the same city, they travel the same route, and they end at the same spot. So what's that saying? That's saying the Mustang distance a little harder equals the Camry distance. Okay, well, how do you find the distance for each one? Notice those are not totals. If it was a total, I'd say it'd be the sum of the two distances, but these are individual distances, so I'm going to say rate times time. See up here on this one, that was a total distance right here. So that's why first I broke it down into the sum of two distances, and then for each one individually, it was rate times time. Okay. So this is going to be rate times time equals rate times time. All right, what's the rate of the Mustang? 89. And I know the rate of the Camry is 62. What's the time of the Mustang? That's X. Okay, so what's the time of the Camry? Now, the Camry leaves first. So is it traveling longer or shorter? It is traveling distance-wise the same, but what's its time? It's traveling longer. See, even if you don't define that, it's okay. You can still get it. All right? Notice here I only needed one variable. There's nothing particularly unusual about this. We did this back in chapter 1. Okay, what are we looking for here? SNARD, speed walking, and a speed running. So we have speed walking. And again, you should pause this thing and, before each of these and, try it on your own first. Okay, this one. Do we know which one we want to know first? No. Do they tell us anything about a comparison of the speed walking and the speed running? No. So here we've got to have two variables because there's no comparison given to us. Okay, so what's the first thing here? Okay. Again, what's this problem about? It's about walking and running. So when we need two big pieces of information here, because we have two different variables. Okay, is that 9 miles about both walking and running? Yes, it is. So that's a big piece of information. Notice the 45 is only about walking. The 20 is only about running. Okay? And then, so we're going to say the total distance, the first total distance equals 9, and the second total distance equals what? 14. Okay, again, each of those, what's the total distance? It's the sum of the two distances. I'm not going to write that down for lack of space. Okay, now how do I find each distance? Okay, so we're going to have rate times time. And that's, you know what, maybe I should write it. Okay, it's going to take up a lot of space, but whatever. Okay, so that's the distance walking plus the distance running. Rumming. I think run has a N, not an M. Distance running, that's 9. And then same thing, distance walking plus distance running equals 14. Okay. Now, how do you find distance then? We've got the rate times time. And again, you don't need to write all this. It's just, this is what you do when you don't know what to do. Rate times time walking plus rate times time running equals 9. And then same thing, rate times time walking plus rate times time running equals 14. Okay, let's continue this up here. Okay, so on the first situation, what's the rate walking? I don't know, that's X, that's what I'm trying to find. Okay, what's the time running? That's 45 minutes. Plus, what's the rate? Sorry, that's the rate walking plus the time walking. Okay, for running, the rate is Y and the time is 20. Okay, for the second day, your rate's still X, but your time is 30 minutes. Running, your rate's Y, but your time is 40 minutes. Now, something you have to be careful of here, just so you understand this. This was minutes, right? Okay, and this distance is miles. This will give the answer in not miles per hour, but miles per minute, which is okay. You just have to be aware of it. What else could we have done? We could have done this in hours. X, well, what's 45 minutes? That's 3/4 of an hour. What's 20 minutes? 1/3 of an hour. Okay, second day, 30 minutes is 1/2 of an hour. And 40 minutes is 2/3 of an hour. And that's 14. And this gives it the answer in miles per hour. Of course, if you do it the second way, you'd multiply the first equation by 12 to get rid of fractions, and you'd multiply the second equation by 6 to get rid of fractions, but actually you'd be dealing with much smaller numbers. It's not that big of a deal, really. The main thing I want to get across here is you have to use two variables because they don't give you the relationship between the two things you're looking for. Okay? Okay, large boxes weigh 50 pounds each and small boxes, blah, 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 blah. How many of each type of box are there? Okay, so we want number of small boxes number of large boxes. And by the way, I realize this is long, but I figured the more examples I go through, the better off you'll be. At least I hope you'll be better off. Okay, do they give us a relationship between these two things? Yes, there are 125 boxes. Okay, so we can get away. You can do it with two variables, But it doesn't matter which one we know first. We'll call this one X. This is 125 minus X. Okay, now what's this say? The total weight, not total number of boxes, but total weight is 5150. Okay, well, how do you find the total weight? The weight of the small boxes. Again, it's not always a sum, but a lot of times it is. And then the weight of the large boxes. Okay, well, how do you find out like all the weight of all the small boxes? You have the number of boxes times the single weight of one box. And then you have the number of large boxes times the single weight of a large box. Okay, well, I'm kind of running out of space here, so I'm going to finish it up here. Okay, so what do we have? Number of boxes. Well, small boxes is X. What's the single weight of a small box? 30. Okay, what's the number of large boxes? 125 minus X. And how many are there? How much does he one weigh? 50. And that equals 5150. Now, by the way, I want to point out, notice each of these terms, there are two terms on the left and then one on the right. They each have an extra 10 in them. So I'm just going to get rid of divide each side by 10, and that gives me 3x plus 5 times 125 minus x equals 515. And now it's pretty simple. Okay. 2 jets, and again, you can pause it and listen to it again. I'm just going to move on. 2 jets leave a city going up, blah, 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 blah. What's the speed of plane B? Okay. So there's only one thing we're looking for, speed of B. Now, is speed of A important here? Yeah, but we're not looking for it, so I don't have to define it. It's fine if we do define it. I'll just stick with this. Okay, so again, what's this about? It's not about distance, rate, or time. It's about plane A and plane B. So what can you tell me about plane A and plane B that's not about speed? Okay, now again, it's kind of hard here because it seems like this 5 hours, the first statement's about speed, so I don't want that. But it seems like both the 5 hours and the 6270 is about both, but it's not really. And I mentioned this in a problem before. I forget which one. I think it was about the Mustang and the Camry. Okay, together, do A and B go 5 hours? No, they don't. Okay, they're going 5 hours individually. That's their individual time. So A and B somehow combined, they have a total distance of 6270. And again, if you have a question on that, ask me. I'm just trying to go through as many examples as I can quickly for those people that kind of get it. Okay, so what's that? Distance of A plus distance of B. Okay, how many times have we done this? So we have rate times time of A plus rate times time of B equals 6270. Okay, well, each one has a time of 5. That's pretty simple. Okay, the speed of plane B is x. Okay, so that just leaves us to find A. So 2 jets leaving the city going opposite directions. A goes 62 faster than B, so that's x plus 62. Again, we could have defined that, just unnecessary. Now, what could you do with this equation to make your life a little easier? Divide everything by 5. All right. Again, notice you don't need Very rarely need two variables. The only ones we needed two variables on, let's see, we didn't need it on 1, we didn't need it on 2, we didn't need it on 3, we didn't need it on 4, we needed it on 5. Why? Because they didn't give us a relationship between the two things we were looking for. You didn't need it on 6, you needed it on 7. Why? Because they didn't give us the relationship between the two things we're looking for. Didn't need it on 8, didn't need it on 9. Even though you could have used two variables on these. But why? Okay, so what are we looking for here? Cost for one movie and cost for one candy bar. Okay. I don't know which one we're going to call X, but I'll say this. Do they give us a relationship between the cost of one movie and the cost of one candy bar? No, they don't. So we're going to need two different variables. Okay, therefore we're going to need two different big pieces of information, not about the movie, not about the candy. It's got to be about both the movie and the candy. I hope this is obvious to you by now. Okay. So we have the total cost, first total cost. Equals 30. Second total cost equals 36. Now, at this point, try and write the equations. Stop the video, write the equations. I'm just going to write the final equations. And if you have questions at this point, you got to kind of need to talk to me. So at this point, then your final equations are going to be 6x plus 2y equals 30, and 3x plus 5y equals 36. And if you don't know how I got that, that's fine, but I need to talk to you. Okay? All right, last one. Now, let me say one thing before we do this last one. At this point, the people in college prep algebra 2 trade can stop. Okay, this is really only for the honors class. I mean, college prep people are more than welcome to listen to it, but you don't need to. Okay, so what are we looking for here? And there's a little note there. You don't really need the note. The reason why I did it is because of the way Alex is going to solve this. Okay, plane A is at an blah, 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 blah. What are we looking for? Time after B takes off. Okay. So, and we're only looking for one thing, so that's all I'm going to do. Time after B takes off. Okay, so this is about plane A and plane B. What do you know? You're at the same altitude. So the A altitude, all these other things are about individually A or B. A altitude equals B altitude. Okay, well, how do you find the altitude they're at? The starting altitude plus the increase in altitude. So we have starting altitude plus the altitude increase. And that's going to be for both of them. Okay. Well, do we know any of that stuff right now? Well, we do know the starting altitude. Okay, so plane A is at 2828. And let's see. And B's taking off. So the starting altitude for B is 0. Okay, altitude. Okay, so, well, how do you figure out how much altitude you gain? It basically comes down to the speed at which you go up times, it's just rate times time, times how long you go up for. If you're gaining like 1,400 feet in an hour and you travel for 2 hours, well, you've gained, 2,800 feet. So just rate times time. All right, so we have 2828. What's the rate of altitude gain? 25.25. Okay. And then the time is x. Because this whole problem starts from wherever at the point at which B takes off. And then the rate is 75.75, and the time is x. So in this case, the time for both of them, even though the plane A has been flying longer, the time is the same for both of them because this problem starts at the moment at which B takes off. Okay? All right, and then you can just solve it, get rid of decimals and solve it. Now, why do I mention this? Alex is going to make you do this problem with two variables. And what are they going to do? They're going to call x time and y altitude. And they're going to make you write two equations. Okay, what would I do? I would do it myself, I would do it the exact same way, okay, that I've done it here. And then what they're going to do is they're going to make you write an equation for A. And what would the equation for altitude be for A? Just the side of the equation that is A. 28 plus 25.25x. And then they're going to make you write an equation for B. And it's just y equals essentially 0, which you can ignore, 75.75x. And then they're going to say, now solve it. And so what would you do? You go back to the equation, that I had written to begin with, because if you write this as two equations and two variables, notice they're both equal to y, so you would just set the two equal to each other. So I don't care if you do it like this way, it's fine. That's the way Alex is going to show you, and it's fine. I just don't really see the point when you don't need to. But that's the reason why I've included this note. Their altitudes are a linear function of time. Because notice, what's this equation right here and this equation right here? They're linear functions. Okay? So that's all. That's all that really means. All right. If you have any questions on any of them, please ask. Have a good day, everybody. I hope this made your day, because it sure made mine.